Channel networks state replacement. So here in our methodology, we go now channel network state replacement, and we're going to discuss how a state is replaced, how an off-chain state is replaced, an old one is replaced with a new one. So we have payment channels and we have state channels. A payment channel is basically about the redistribution of assets. So you send monetary amounts from one user to the other. And in a state channel, you should ideally be able to play games, voting, auctions, etc. So smart contracts, but in an off-chain way. So the first payment channel that were proposed are by Spillmann et al. And then duplex micropayment channels are were followed up, and then Lightning came about. In the state channels, I can recommend you to look at the Sprites paper, the Broom paper, or for example, Kitsune. So state replacement just means we want to replace this state here with a new one, right? And this replacement here is equivalent to performing a payment, right? From this entity to this entity of 0.1, right? It's the transfer here of this particular asset. And so it's really important because we don't want to perform an on-chain transaction, right? This is here the on-chain transaction, this is the off-chain state transition or state replacement. So now let's look at the first example of how we can do such a replacement, and that's with time locks. So in a transaction, what you could say is the time lock here is 100. This means that this can be an on-chain transaction. So you can treat it similar to a regular on-chain transaction. So that's a regular on-chain transaction, but it cannot be included in the blockchain unless 100 blocks passed, right? So this means here so it can only be included in the blockchain in 100 blocks. So this means you can naturally update the state with a new time lock of 99, and here you perform a transfer of 0.1, right? This is plus 0.1 in this direction. So this particular transaction, you can include it in the blockchain earlier, right? Before that one, and so on, right? That's a time lock replacement. So what's the advantage or disadvantage? Well, the lowest time lock is first included in the blockchain, but the problem is we can only perform 100 off-chain transactions here if the time lock is 100. Right? So there's a limit to the scalability of this particular payment mechanism, off-chain payment mechanism. There's also the so-called revocation state replacement. That's what Lightning uses. So we have here again the funding of the parent chain transactions. After the parent chain transaction, then we have here, this is the initial state where we performed a transaction, and then this is here the second state. So what happens is if these are two conflicting states, like the adversary tries to close this particular state, so he writes this state in the blockchain, in this particular block I, and then later the honest peer disputes by providing this later stage, and the both users have signed off here on those states. So the blockchain will see, okay, this is the more recent state, so I can reject the fraudulent state. And because the adversary performed a malicious action, he gets a punishment. The punishment consists of losing all the assets that are in the channel. So all assets of the channel go to the honest guy. Okay. So there are a few state replacement techniques that were proposed over the last years. So Spillmann was the first one. This was replaced by incentive. We discussed replaced by time lock. We discussed replaced by revocation, and basically the older the protocol, the more complex they become, right? So and Bitcoin's model makes it really challenging to remove this expiry time and to remove these throughput limitations of an off-chain transaction. So what about the state replacement techniques after 2016? So we can do a replace by a version. So we have a signature from the party A, we have a signature from the party B, and then we have the hash of the state I, and and here a counter I. And with this particular version, right, version I, you can replace the state as you go on. And this is something that's being used by more modern off-chain protocols such as L2, Sprites channels, or Perun channels. There are different blockchains each.